warahmatullahi wabarakatuh and salam sejahtera. This is the example of dual combustion engine and this question is from final exam March 2016. So this is the question and the question asks us to to sketch the PV diagram and to determine from question A up until question E. So this is the information. So we use this information to solve the question. Okay, so this is the PV diagram. Okay, since this question mentioned about the ideal dual cycle, so it means that the heat addition occurs at two process. One is in constant volume and one is in constant pressure. Given RV compression ratio is 18 and compression ratio is V1 over V2 and V1 is equal to V5 and V2 is equal to V3. Mass is 0.1. Cut-off ratio is V4 over V3 and is equal to 1.3, and given here pressure ratio at constant volume is 1.1. So at the constant volume is here, so it means that P3 over P2. Okay, so the question is find the heat addition at constant volume. B, find heat addition at constant pressure. So first thing first, we have to find T2, T3 and T4. So we start with 1, 2, 2. This is isentropic compression and this is the data given. So we use formula hijau and we get T2 as a 978.72. So please be careful when you do the calculation. Okay, and here V2 over V1 is 1 over RV. Okay, next we go to 2 to 3. This is constant volume heat addition. So we use the ideal gas equation to find T3. So P2 V2 over RT2 is equal to P3 V3 over RT3. Then we cancel V and R. Then we get the relationship between T and P and we get T3 as 1078.595 Kelvin. Okay, next we go to 3 to 4. This is constant pressure heat addition. So we have heat addition 2 here. One is at 2 to 3 and one is 3 to 4. Constant volume, constant pressure. That is why we call it as a dual cycle. Okay, so 3 to 4, okay, we use ideal gas equation relating state 3 and state 4. P3 V3 over RT3 is equal to P4 V4 over RT4. Since this is constant pressure, so I cancel P3 and P4 as well as R. Then I get this relationship between T and V. So I get T4 as 1399.574 Kelvin. Next, we proceed with process 4 to 5, that is isentropic expansion. So as I mentioned, if there is an isentropic, we use formula hijau. T5 over T4 is equal to V4 over V5 to the power of K minus 1. To find V4 over V5, I have to modify this equation. Okay, I use chain rule. So what is chain rule? I modify V4 over V5. So V4 over V5 is also equal to V4 over V3 multiply with V3 over V5. Okay, V4 over V3 is cut-off ratio and V3 over V5 and this is 1 over compression ratio. Okay, then we get the value of V4 over V5 is 0.0722, and from this value we replace here. Then we get T5 as 489.175 Kelvin. So when we get all the temperature at each state, then we can find question 1 and question A, B, C, D, and E. So for question A, find heat addition at constant volume. So this is the formula and this is the answer. Question B, heat addition at constant pressure. So this is the formula and this is the answer. C is work net. Work net is Q in minus Q out. Okay, so we have to find Q out. CV T5 minus T1 multiply with mass. Then this is Q out. So I get W net as Q in minus Q out as a 26.482. Lastly, question D is thermal efficiency, which is W net over Q in. This is the formula and this is the answer. And MEP if the pressure 1 is equal to 100 kPa. So please be careful, if you write down W net in capital letter, then volume must be in capital letter. To find V1, we use ideal gas equation, then we get V1. Okay, so from V1, we get the MEP. And the value of MEP is 317.912 kilopascal. So that's all for now. Thank you.